Welcome to Lesson 8, Introducing the Quadratic Formula. So today we're going to look at what the quadratic formula is, where it comes from, and when do we use it. So first I want you to try to solve this problem, x squared minus 3x minus 2. And if you tried it to factor this, you will realize that there's no two values that are going to give us a product of negative 2 and a sum of negative 3. So in other words, this equation is unfactorable. So we can't actually use any of the factoring methods we've seen. So we need another tool to help us factor or another tool to help us find the solutions to this equation. So here is where we get introduced to the quadratic formula, which is a new algebraic tool that's going to help us to solve a quadratic function that's really hard or sometimes impossible to factor using the common factoring methods that we have seen. So when you have an quadratic equation of the form ax squared plus bx plus c, we will use the quadratic formula, which looks like this. So it tells us that the solution of x is equal to negative b plus or minus the square root of b squared minus 4ac, and all of this is divided over 2a. So now those a, b, c's come from our quadratic function. So a is our coefficient of x squared, b is our coefficient of x, and c is our constant term. So if you substitute those values, you should get your x values or the solutions of x, which are the roots to your function. So now I want you to think first, what is the maximum number of solutions the quadratic formula gives? So specifically, look at it one more time. We have this plus or minus here, which means that one time when you're solving for x, you're going to add whatever the value of the square root is, and the second time you're going to subtract. And that's what we've been seeing with our parabolas as well. They usually have 0, 1, or 2 solutions. So the maximum number of solutions it will give us is actually 2. And the next thinking question I have for you is, why is it easier to use the quadratic formula if your function is already in the standard form f of x is equal to ax squared plus b of x plus c? So to answer that, you would be looking at what the formula for quadratic formula is, and the values you're using in there are a, b, and c. So when you already have your function in standard form where a, b, and c are very evidently clear, it's way faster for you to apply the quadratic formula because you can just substitute those values in and you're not doing any additional work to expand and simplify and collect like terms. So point being, if your function is in a form other than the standard form, you do have to expand, simplify, and collect like terms in order to get it to that standard form so you can find the values of a, b, and c to substitute in the quadratic formula. Okay, so now let's try solving that same problem we saw above, x squared minus 3x minus 2. So here, a is 1 because the coefficient of x squared is just 1, b is negative 3, and c is negative 2. And our quadratic formula tells us to set this up, I'm going to just start with x for now, as negative b plus or minus the square root of b squared minus 4ac. And all of this over 2 times a, which is 1. Now, this is just solving an equation with just one variable. Apply your order of operations here. We actually aren't even solving for a variable on this side, so it's even easier, so plus 3. And if we simplify this a little bit further to get... So now is where I'm going to split my solution into x1 and x2. And the first time I'm going to add the square root of 17. And the second time I'm going to subtract square root of 17. And please use a calculator for this part and stick with square root of 17 until your final answer. Don't find the decimal of that and work with decimals because it does alter your answer just a bit. So here we get 3.56. And if we do the subtraction, we get negative 0.5. 0.56. And if we write our values here, negative 0.56, doesn't matter the order as long as you know that they are both the roots or the solutions. And so now we do have two x values where this quadratic will intercept the x-axis, and this happens at when x is equal to negative 0.56 and at 3.56. So now we're going to look at where does the quadratic formula come from. So remember, we want to start with our equation in standard form. So we have ax squared plus bx plus c. And the quadratic formula helps us find solutions to the function when it is equal to 0. So had I not had this formula and I wanted to just solve for x myself, um, is pretty much what I'm going to be doing. I'm going to do some algebraic manipulations here to get x on its own and see what my answer would be. So first, we're going to isolate c to the other side so that I have my two terms with x on their own. Now, I'm going to divide by a all the way through to get. And keep in mind, even though c is on the other side, when you do divide by any term, you are dividing that whole equation by a to make this true, which means that this is divided by a, this divided by a, and this is also divided by a. So do not forget about that negative c that's on the other side. That has to be divided by a as well. So now we're going to, you'll see why I do this later on, but for now, just trust that I'm going to, from here, add this term to both sides. I'm adding the same value to both sides, so I'm not actually changing anything because these two are the same. So now the same equality will hold. Now this first side, our left side, is actually a perfect square, where here we have 1 squared, and this on its own is b squared over 2 squared, or 4. So using this, we can rewrite this as x plus b over 2. Oh, and sorry, don't forget about the a. The a is there as well. The a squared. Oh no. So now I have this squared. So take a moment, sit with that, make sure it looks okay to you. And now on the other side, I am just going to find a common denominator for a squared and write this as, and I'm just going to do a little bit of rearrangement there. And maybe it's starting to look a little familiar to you now with the quadratic formula. So our next step is to find the square root here of both sides. But keep in mind that with square root, I'm essentially distributing it over the fraction because 4a squared can just be 2a. And then on this side, I have x plus b over 2a. And my final step is to isolate x by moving that b over 2a. So let's just keep this for now. And now we can combine this with that 2a because they have the same denominator. And what I'm going to do is I'm going to move that b over. And here, I made a small error and I came to notice it as I was doing it, but that's okay. Part of math is as you make mistakes, you'll realize later on that something doesn't add up. So you go back and you correct it because I forgot here when we do square root, we need that plus or minus, and that plus or minus is going to be carried through. So that here, when I move it over, we have plus or minus b squared minus 4ac, and that's my value of x. And now this is just the quadratic formula. So you're not expected to know how to derive this or how to come up with this. It was just to show you where it comes from. It's essentially trying to solve for x starting with the standard form. But lucky for you, you're going to be given the formula, so you just have to work on applying it. So how do you apply it? And here we have the steps. So first, make sure that your equation is the standard form and that it equals to 0 because we're looking for the roots, and that happens when our output value is 0. Next, try to find a, b, and c based on your standard form function, and then substitute that into the formula. And then you're just simplifying and solving to get between 0, 1, or 2 values of x. So now let's see how that would work out. Starting with our first example, we have x squared minus 30x plus 225 is equal to 0. So if you recognize this right away, 225 is one of our perfect squares. So C is actually 15. And this whole function to begin with can be written as a perfect square of x minus 15 squared because we have that negative 30 there. So you would be able to find the solution right now, just visually looking at that, the solution would be 15. So we're going to try with the quadratic formula. So we will write, let me start A, x is equal to negative b, so 30, or let me rewrite it like this for now, just so we don't confuse that where I lost that negative. Negative b squared, minus 4ac. And all of this will be over 2a, so just 2. So try this part using a calculator and check back to see that you got the same answers as me. So if you tried this, you should have actually got that this will be 0 over 2, and our final answer is just 30 over 2, and it's 15. So because the square root was 0, we didn't actually end up using that plus or minus here. So we only ended up with one solution. And that happens. And that happens in the case of our perfect square examples. And that is one of the possibilities of the quadratic formula. So now let's look at example B, where we have x is equal to negative b plus or minus b squared minus 4ac over. And now we have our first example where a is not 1, so we have a different denominator. So solving this here, you should get and at this point you should have stopped and been like, because you do not know how to do a square root of a negative number. So for this point, for this level, you would just stop it there and we would just say that this part is not solvable, or you would just say no solution. And so that would mean that there is no solution to this equation, and that is a second possibility of the quadratic formula. And let's look at our last possibility for C, where x is negative b. And with this one, there was a little bit of a trick to it because it's not right away is equal to 0. So you do have to do a little bit of change to get the correct value of a, b, and c. So now, plus or minus b squared minus 4 AC. And all this over 2A, so 2. And solving this, you should get 5 plus or minus square root of 33 over 4. And now you will try x1, x2 by one time adding and one time subtracting. And we'll use a calculator. Okay, so if we add, we should get 2.69. And if we subtract, we get negative 0.19. And so here we have two solutions. So you've seen the case now with one solution, no solution, and two solutions. So what does it mean when there are no real solutions now? So in the example B, we did see the algebra of it that when there's no solution, it pretty much means the square root is negative. But what does that mean for the graph of it? Graph of the function. So what does a graph with no real roots look like? And it's pretty much these two parabolas that are here. It's a parabola that does not intersect the x-axis because the way that it has been transformed, it simply will just not cross the x-axis. And in those cases, we would get the quadratic formula would give us no solution. So now we have a application question for the quadratic formula, where you are told that the profit on a school poetry slam night is modeled by the quadratic equation p of x is equal to negative 60x squared plus 790x minus 1,000. And p of x is the profit in dollars, and x is the price of the tickets also in dollars. Our first question is, at what ticket price will they break even? So break even here is our key vocabulary here, and that is pretty much when the profit is equal to 0. So however much they made from that night and however much they spent on that night, it was the same. So they actually didn't make any profit because their cost and revenue was the same. So that is the same as setting for A, P of x is equal to 0. Or if we just use our function 790x 1,000 is equal to 0. And so you may be able to try some factoring here. Right away, I see you can factor out the 10 for sure from from all terms, and possibly you can go even deeper and see if there's other factoring tools. But now that I have the quadratic formula, I can just apply that right away and save myself a lot more time. So x here is negative b plus or minus b squared minus 4ac. And also make sure your square root is covering everything. If you leave a bit of the last term out, it's unsure if that number is also within the square root or not. And divide by 2a, so negative 60 here. Now, this would be equal to, if you do the calculation with your calculator, you should get 384,100 over negative 20. And now if you try to solve for x1 and x2, you will get and we definitely here want to round to decimal points. Generally, we round to 2 decimal points anyways, but here, because we're working with the dollar values, we definitely want to switch to the 2 decimal points. And so remembering x was the price of the ticket, so then that makes sense. If their ticket price is $1.42, or if it's $11.75, they will break even. And the justification for that could be that if they sell a cheaper ticket, then they might be selling way more tickets, way more number of tickets, and ultimately result with more like enough costs that they break even. And if they're also selling more tickets or selling a ticket at a higher cost, they're also selling fewer tickets. So that could also explain why they're breaking even. And question B, we're asked, at what price should the English department set the tickets to maximize the profit? So knowing that they break even at those 2 points, we will try to visualize our function. Okay, and so if we are visualizing that, we kind of picture our ticket price, which is X, and P of X, which is our profit. And keep in mind that A is negative, so we will have something that will look like this. And so we see that at two different points, it will intersect with the x-axis, which is our 1.42 and 11.75. So any ticket price that they sell above this value or between these two values, so whether it's $2, $5, $10, that would give them a profit, a good profit. But we're asked how we can maximize this profit. So we know that our maximum value occurs at this middle value, which is between 11.75 and 1.42. So we just get the average of those two to be 6.59. So, and we are asked at what price should the English department set the tickets to maximize their profit. So we just need the ticket price. So we would say at ticket price, $6.59. And that is the conclusion of our lesson for today. So I hope you got familiarized with the quadratic formula, and we do have a brief assessment for this lesson to test everything you learned because this is a very key concept. So I just want to make sure we know how to use the quadratic formula and we feel comfortable with it before continuing on to more advanced quadratic function and real-world problems. See you all next class.